Now, getting prepared for the final exam. The first thing you should do is go to the math website, math.uncc.edu. And on there, you're going to see some old final exams. My strong recommendation is you should go back and look at some old final exams and practice. It's a departmental final exam. So you're going to get a feel for what the exam is going to look like for you guys. When is the final exam? December the 11th, which is a Friday. At what time is your final exam? 8 o'clock in the morning. Oh no, it gets better. But that's when you open your exam booklet and start taking the exam. You remember the old SAT stuff. So you got a lot of stuff to do before you take the exam. You got to fill out the ObScan sheet. You got to come in with your student ID. Oh, it's a big to-doings from the math department. Therefore, you have actually got to be at the exam at 7:30 in the morning. I kid you not. 7:30 in the morning, because the exam starts at 8 o'clock. And once the exam starts, no one's allowed to come in after the test booklet gets open. Okay? Well, I'm sorry, you signed up for college algebra. It's been in the exam schedule for a year now that you guys will have it at 8 o'clock in the morning, which does mean, honestly, you'll have to be there at 7:30. Now, where is our exam going to be held at? Fretwell 121. Now, all this stuff that I'm announcing, I'm putting on your Moodle site, okay? So go to the bottom. It's not up there yet because I'm still typing this stuff in. Then I got to go teach a class. But it's going to be on your Moodle site by the middle of the week. So I will make all this announcements and stuff once again. But the final exam is going to be in Fretwell 121, which is just up the hall. The other thing is this. What I do every semester is with my classes on reading day. There's something called reading day, which is the day before the final exam, which will be December 10th. That's a Thursday. You do not have any classes on that day. It's a day for you to actually cram for exams because they start the next day. So the university gives you one day of no classes just to study. And on that day, a lot of us give review sessions. And I am very famous for giving my classes a review session. I'm going to give a review session. I believe it's going to be at 2:30 in the afternoon in here. And I'm going to give a review session where I'm going to go over last semester's final exam. And I'm going to do every problem on there. Because you understand, the math department is made up of mostly guys like myself. So when they make up an exam, they'll look at last semester's exam or whatever, look at those questions and go, huh, and make up something very similar. So you should practice old final exams. And I'm going to do last semester's old exam and go through every question and talk about what they're looking for stuff. Great way to study for the exam. Yes, ma'am.
Will last semester's be on the website for us to see already, or will they just be like older ones than that?
I believe it's just older ones than that. I will get one of the last semester's exam, and I will actually post it on our Moodle site. So it'll be something special for you guys. But here's the deal. I haven't put it on our website yet, but I'm going to. But this is also what I do. I am very famous in the math department and in university. When I set up one of these review sessions, a lot of people like to horn in on it. I make these review sessions for you guys to make sure you guys do well. But if you happen to have a roommate or a friend that's in some other person's class that wasn't fortunate enough to be in my class, you can invite them along if you want to, and give them a copy of the exam and bring them along. And the math department knows that I always make it open to everybody. So once I announce it to you guys, the math department and the other faculty are going to announce it to their students where I'm giving my review session at. So there's going to be a lot more students here than just us. Okay? I want to make sure you guys are here and sitting on the front rows first off. Because I'm doing it for you guys, but of course, anybody who wants to learn, I'm more than happy to try to help them out and try to help increase their grade or whatever. So if you've got a friend that needs some assistance, let them know about it and bring them in here and we'll work together. And you can give them a copy of that exam or whatever, give them access to it, because I'm going to do last semester's exam, and I don't think that's on the internet, but I have a copy of it, so you guys will get a copy of it. and we'll do that one. So, and then you, again, on the website, math website, the older exams, you should also look at those things. Don't just do one exam and think you know everything, because occasionally they'll skip that question last year, but they had it on the year before, and they're gonna put it again on this year. So make sure you go back and do a couple of years and just practice. The more you practice, the better off you're gonna be. All right, so let's go ahead and get started. We're in, and again, all the stuff that I just talked about, I'm gonna put on our Moodle site, and you will see it by Wednesday. I will have it all typed up for you guys and with all the information and stuff, okay? We are in the last part of section 6.1. Chapter 6 only had one section we were supposed to cover, chapter 6.1, and we've done 2/3 of it. There's this last little bit. It is called solving rational inequalities. They love these kind of problems, and I can bank on you guys having one of these kind of problems on the final exam. So therefore, there will be one of these problems on my next test. All right. And I try to give you guys steps on solving rational inequalities. Now, first off, you have a rational function, which is a polynomial over a polynomial. And it's going to be inequality less than or equal to, greater than or equal to, less than, greater than, some type of inequality to some kind of number. The first thing you want to do is you want to rewrite this expression and always set it to 0. So you can create this function as either greater than or equal to 0, less than 0, greater than 0, less than 0, whatever. All right? Then what you do is you set both the numerator and denominator equal to 0. The numerator is equal to 0 is called the x-intercept or root. You can tell when you want one of those guys if you have equal to or not equal to. The denominator, when you set it equal to 0, those are points that do not exist because you can't divide by 0. So they're going to be little open circle points that do not exist on your answers. You can't have these as answers. And then what you're going to do is you're going to do our classic number line that we talked about before. We're going to put a number line on this thing with our zeros and the vertical asymptote denominator is equal to 0 points. And we're going to do test values on this thing. And based upon the inequality, if it's greater than or equal to 0, we're looking for the positive terms. When it's less than or equal to 0, we're looking for the negative terms, so forth and so on. And then we can figure out from that which intervals should be our solutions, and we got our answer. So here's kind of my steps on involved, but let's do an example so you guys will see this one. This one's actually a pretty nice one. Don't worry, I got some crappy ones in the next couple of problems here. This one's nice. I've got the equation, or inequality, negative x minus 3 divided by x plus 2, less than or equal to 0. Okay? The first thing I want to do is find the zeros and find the domain restrictions, the vertical asymptotes. So the first thing I want to do, I've already got my function equal to 0. So my function, I'm just going to call him f of x, would be negative x minus 3 over x plus 2. Now, what I'm going to do here is I'm going to take my function and I'm going to set it equal to 0 because I want to find the zeros. But basically, when you set it equal to 0 and you multiply by x plus 2 on both sides, the x plus 2's cancel, you're left with negative x minus 3 equals 0 times anybody is 0. So when you set a fraction, a rational function equal to 0, when you multiply by your denominator, it's just like setting the numerator equal to 0. Solve for x. I would add 3 to both sides. I get negative x equals positive 3. Then I divide by negative 1 on both sides, and that gives me x equals negative 3. Now my question to you, this is the numerator equal to 0, called the 0. Do you want this answer in your solution set? Does the interval, and because remember, we're trying to find the solutions to the equation, negative x minus 3 divided by x plus 2 is less than or equal to 0. Do you want the 0 point to be in your solution set? Yes or no? The answer is yes. Why? Because of the equal to in the inequality. If you have an equal to in the inequality, you want your 0, the numerator equals 0. So I'm going to put a little filled in dot on him to remind me I want this guy. Also, set the denominator equal to 0. My denominator is x plus 2 equal to 0. When you solve for x, you get x equals negative 2. But you see this point right here, this is where the denominator equals 0. And what number are you not allowed to divide by? 0, which means you always want to exclude this number from your number line. You cannot have this number on your number line because when you plug in x is -2, the original function does not exist. So, you want steps? I give you steps. First step is make sure your function is set to 0. Second step, and clean it up as a fraction. Set the numerator equal to 0 and solve and decide whether you want him in your solution set. And the other one, set the denominator equal to 0 and always exclude him from your solution set. So step number 3 is draw yourself a number line. And put these numbers in order on your number line. -2 and -3. Well, -3 would be less -2, but -3, because it's to 0 and we was equal to 0, we want to include that guy. So I'm going to put a filled-in dot, or a bracket, if you will, to make sure I include that in my answer set. The other number was -2, but that's going to be an open circle on that guy because I cannot include him in my answers because that's where the denominator equals 0. And what we're going to do here is we're going to do test values on my function. -x minus 3 over x plus 2. Remember, we're trying to figure out where it's less than or equal to 0. So now you've got this number line with your 0 and the vertical asymptotes where the denominator equals 0. Pick some numbers in each interval. Pick a number that is less than -3. Good choice, -4. So and I'm going to plug it into my function, -4. This would be equal to -4 minus 3 over -4 plus 2. Now I could use a calculator on this thing, but I don't need to. Let's do some math in our head. What's a -4? 4 minus 3. 1 over, what is -4 plus 2? -2. And 1 divided by -2 is a -0.5. I don't care what the number is. Because you're comparing it to 0, we care about the sign of it. What is the sign of this number? Negative. So everybody in this interval will be negative. Does that make sense? Now, let's do another test value. Pick a number between -3 and -2. And I'm sorry, but they made up the problem. I didn't. Between -3 and -2, what number do you think of? Yep, I'm going to go fractions on -2.5. And plug it into my function, -2.5. This would be -2.5 minus 3 divided by -2.5 plus 2. A negative of -2.5 is 2.5. Minus 3 is a -0.5. -2.5 plus 2 is a -0.5. And -0.5 divided by a -0.5 is 1. But no, I don't care what the number is. What's the sign of it? It's positive. So everybody in that interval is going to be positive. Does that make sense? Now, pick a number you should bring bigger than -2. Good choice. 0. Always, if you can plug in 0 into the stuff, it's easier. So f of 0. This would be -0 minus 3 over 0 plus 2. A -0 is still 0. Minus 3 is -3. 0 plus 2 is 2. So I get -3/2. Don't care what the number is. What's the sign of it? Negative. But what were we looking for? So we're trying to solve, remember your equation, the equation -x minus 3 over x plus 2 is less than or equal to 0. What kind of numbers are less than or equal to? Less than 0? Negative numbers. We're after the negative numbers. Does that make sense? Where are my negative numbers at? In here? Over here. Traditionally, we want the answer in interval notation, which runs right off the number line. This arrow right here represents negative infinity. You read a number line like you read English from left to right. So negative infinity, parentheses, negative infinity up to -3. But you see that filled in dot? -3 is where it's equal to 0. And because we have equal to 0 here, I wanted to include that point. In interval notation, how do you include a point? you use a bracket. Union, where's your next interval at? -2, but you can't have -2 in the answer, so that would be a parenthesis, -2, comma, infinity. Does that make sense? And that's your solution. Does that make sense? Catch a pattern. Rational inequalities, we do the same thing every time. Turn page. They're going to try to make them hard for you guys. So let's practice. 1 divided by x minus 3 is less than 1. The first thing you have to do with these kind of rational functions, when you're trying to solve a rational inequality, is set it to 0. So what's my first move? Subtract 1. Pull everything to one side. I'm going to subtract 1 from both sides. This is going to give me 1 over x minus 3 minus 1 is less than 0. Always compare to 0, because that's where the plus minus stuff comes in off your number line. You always got to pull stuff to one side. Now, traditionally on this particular problem, I like to make big fractions out of this stuff. So to make big fractions, you got to have a common denominator. What's my only denominator in this problem? X minus 3. So this guy already has an x minus 3, so it's 1 over x minus 3 minus, this is a fraction, 1 over 1, but I want the denominator to be x minus 3, so I'm going to multiply by x minus 3, but whatever I do to the bottom, I got to do to the top. Whatever I do to the denominator, I can do to the numerator. Still less than 0. Now, this is 1 times x minus 3, which is x minus 3. You write it as one big common denominator, x minus 3, and all this stuff goes in the numerator. 1 minus 1 times x minus 3. Less than 0. I'm going to clean it up. That negative 1 is going to distribute. This will be 1 minus x plus 3 over x minus 3 is less than 0. And then one more move, combine like terms. What is 1 plus 3? 4. This will be negative x plus 4 over x minus 3 is less than 0. So they're making it hard on you guys because they're going to make you pull everything to one side and then common denominators to turn it into one big fraction. Does that make sense? So therefore, here it is. My function f of x is the guy we compare to 0. Negative x plus 4 over x minus 3, and we're going to set it less than 0. Two things I want. I want to know where the numerator is equal to 0 and where the denominator is equal to 0. So, to find the 0, we set the numerator equal to 0. Now, the numerator is negative x plus 4. Set it equal to 0 and solve for x. Subtract 4 from both sides. I get negative x equals negative 4. Divide by negative 1 on both sides. I get x equals 4. Question. Do you want this 0 in your solution set? Yes or no? Why not? Because the equation, when you clean it up, it's still, any of them will do, it's not equal to. When you want the 0 when there's an equal to in it, right? So you're going to put an open circle on this guy. Now set the denominator equal to 0. This is where the function doesn't exist at. You always have to omit this one. You get x minus 3 equal to 0. Solving for x, x equals 3. That always gets an open circle, because the denominator equals 0 is where the points don't exist. Yes, ma'am?
Why wasn't the 4 included?
Because the 4 is not included on this one because my inequality does not have equal to in it.
Okay.
Only equal to. If you look back at the last problem, let me refer back to that one. We included the 0 on that one, but the inequality had the less than or equal to 0. That equal to 0 means you want to include the 0. This one doesn't have the equal to, so you exclude the vertical asymptotes as well as the zeros. Exclude everybody. Now, remember this. This is an inequality. You expect to have interval answers, so I've got to draw my number line. My function that we're comparing was, after we cleaned it up, was negative x plus 4 over x minus 3. And remember, we're trying to find where that's less than 0. Put my numbers on my number line in order. I got 4 and 3. Well, what comes first would be 3 and then 4. But they both have open circles. Does that make sense? Because the 0, we don't include the 0 because it didn't have equal to on the inequality. We never include where the denominator equals 0 because that's where the function doesn't exist at. And let's do test values. Pick a number, use your brain, less than 3. Good choice, 0. So here's f of 0, which would be negative 0 plus 4 over 0 minus 3. When I clean that up, that's negative 4/3. I don't care what the number is. What's the sign of it? Negative. Pick a number between 3 and 4. Sorry, they made it the problem. I didn't. So what's the number between 3 and 4? 3 halves. So f of 3.5. That would be negative 3.5 plus 4 over 3.5 minus 3. Well, let's see here. Negative 3.5 plus 4 is what? Negative 3.5 plus 4. Positive 0.5. What is 3.5 minus 3? 0.5. What's 0.5 divided by 0.5? 1. And it's positive. You have to do test values. Remember, they just don't always alternate signs. Minus, plus, minus, plus. Sometimes it's minus, skip something, minus some more, then plus. You actually have to do the test values. Pick a number bigger than 4. I choose 5. F of 5 would be equal to negative 5 plus 4 over 5 minus 3. Negative 5 plus 4 is negative 1. 5 minus 3 is 2. It's negative 1/2. It's negative. So, what's my answer? What kind of answers are we looking for? Once we set it to 0 and got our like terms, here's my question now. It's less than 0. Less than 0 means we're looking for who? We're looking for the negatives. The negatives are between negative infinity to 3 and 4 to infinity. So we would write this as negative infinity to 3, open parentheses, can't include it, union, open parentheses, 4 to infinity. And there's my answer. Does that make sense? Well, let's see if they can make it worse. Try this problem. 4 divided by x minus 4 is greater than or equal to x. It's an irrational fraction inequality. What's the first thing you have to do? Step 1. What you always have to do, step 1. Set it to 0. What's the easiest way to set it to 0? I'm going to subtract x from both sides. This is going to give me 4 divided by x minus 4 minus x is greater than or equal to 0. Now, you've got to get a common denominator. This x is a fraction. Let me help you out with that. It's now x over 1. What is your common denominator? X minus 4. So now you've got to get a common denominator. So it'll be 4 over x minus 4, which it already had, minus x over 1, but you want the common denominator of x minus 4. So I put it on the bottom, and I put it on the top. Still greater than 0. So I multiply the top and bottom by x minus 4. Now you've got, this is 1 times x minus 4, which is x minus 4, so this is your common denominator of x minus 4. Your numerator is 4 minus x times x minus 4. Greater than or equal to 0. Let's keep cleaning it up. I would distribute. This gives you 4 minus x squared plus 4x divided by x squared minus, We got x minus 4. Let's clean up the greater than or equal to 0. Let's clean that up. I like to write polynomials in decreasing order, but you got to keep the sign there. It's negative x squared plus 4x, and that's a plus 4, understood, divided by x minus 4 is greater than or equal to 0. There's my function. We want to solve for this. So, we want to find where the vertical asymptotes are at, and we want to find where the zeros are at. Does that make sense? So let's find the zeros first. To find the zeros, I've got a fraction equal to or greater than or equal to 0. To find the zeros, you set the what? Set what equal to 0? Set the numerator. Numerator equal to 0. This would be negative x squared plus 4x plus 4 equal to 0. Does that make sense? Then you try to factor it. How does negative x squared plus 4x plus 4 factor? Well, you can pull out the negative 1 if you want to, or move everything to one side, but here's your problem. It doesn't factor. What are you going to do if you've got a quadratic that doesn't factor? Quadratic formula. So, if I used a quadratic formula, a is equal to negative 1, b is equal to 4, and c equals 4. With me? What is the quadratic formula? If you know it, please sing along. X equals what? Negative b plus or minus square root b squared minus 4 ac all over 2a. Plus or minus, there's two answers. Told you this quadratic stuff come back and haunt you. I think it's been on every test and it'll be on this one too. Negative b, that'll be negative 4 plus or minus the square root of b squared, 4 squared minus 4 times a, which is negative 1, times c, which is 4, all over 2 times a, which is negative 1. All right, clean it up. Negative 4 plus or minus the square root of, what's 4 squared? 16. What's negative 4 times negative 1? Excuse me, times 4. Plus 16. All over negative 2. What's 16 plus 16? Yep. X is equal to negative 4 plus or minus the square root of 32 divided by negative 2. Can you clean it up some more? Sure you can. What's the square root of 32? What times what is 32? 16 times 2, right? What's the square root of 16? All right. So this is negative 4 plus or minus 4 square roots of 2. Because 32 is 16 times 2. The square root of 16 is where the 4 came from. All over negative 2, but you can divide each term by negative 2. What is negative 4 divided by negative 2? 2. Plus or minus, what's 4 divided by negative 2? Negative 2 with the plus or minus is still plus or minus 2. Square roots of 2. Yeah, they gave you these lovely problems. By the way, how many zeros are there? How many? How many zeros are there? There are 2 of them. What are the 2 zeros? X equals 2 plus 2 square roots of 2, and x equals 2 minus 2 square roots of 2. Does that make sense? It's the plus or minus. The quadratic formula always gives you 2 answers. Did I lose you guys anywhere with this? Now, because I'm going to put it on a number line, I am going to put it on my calculator. 2 plus 2, oops, 2 plus 2 square roots of 2. I got 4.828, good enough. And let me do this now so you guys can see. Oh, I really am typing this thing in. There you go. And what is 2 minus 2 square roots of 2? I got x equals negative 0.828. Just want to figure out where these guys are located on the old number line. Question for you. Do you want your zeros in this particular problem? Yes or no?
Yes.
Why? Because the equal to. Remember with this original problem had greater than or equal to? And so when you play around with your fractions, we got it down to this, it's still greater than or equal to. So we want these guys to be filled in dots. The other guy is the vertical asymptote. You set the denominator equal to 0. X minus 4 equals 0 means x equals 4. And x equals 4 is always an open circle because you can't divide by 0. So, let's draw ourselves a number line. Does that make sense? And put our numbers on there in order. I've got, here is 2 minus 2 square roots of 2, also known as x equals negative 0.828. I've got x equals 4. And I got x equals 2 plus 2 square roots of 2, which was what? 4.828. And my zeros I want to include, but the vertical asymptote denominator equal to 0 always has to have an open parenthesis. And here's my function. Yeah, I know I'm running right into this problem here, but they made it up. So f of x is equal to, what was my function here? When I cleaned it up, it was negative x squared plus 4x plus 4 divided by x minus 4. And we're trying to figure out where this sucker is greater than or equal to 0. So here's my function right here. So pick a number less than 2 minus 2 square roots of 2. Pretty much a number less than negative 0.828. Negative 1, good choice. F of negative 1. When I plug it in, this will be negative 1 squared plus 4 times negative 1 plus 4 over negative 1 minus 4. Negative 1 squared is 1. Negative that would be negative 4. Obviously negative 1. Minus 4 plus 4, which cancels out, over minus 1 minus 4 is negative 5. I get 1/5. When I clean it up, I don't care what the number is. What's the sign of it? Positive. Pick a number between, I gotta love this, negative 0.828 and 4. Use your brain. Good choice. 0. F of 0 would be equal to negative 0 squared plus 4 times 0 plus 4 over 0 minus 4. 0 squared and 4 times 0 is 0. I'm left with 4 divided by negative 4. And 4 divided by negative 4 is negative 1. It's negative. Pick a number between 4 and 2 square roots of 2. 2 plus 2 square roots of 2. Between 4 and 4.828. 4.5. Okay, fine. 4.5. And I'm going to use a calculator on this one. F of 4.5. This would be negative 4.5 squared plus 4 times 4.5 plus 4 all over 4.5 minus 4. Negative, parentheses right in the numerator. Negative parentheses 4.5 squared plus 4 times 4.5 plus 4 divided by, close parentheses, divided by parentheses, 4.5 minus 4. What number did I get? 3.5. Don't care what the number is, sign of it's positive, so everybody in that interval is going to be positive. And then last but not least, pick a number bigger than 4.828. 5. F5. This would be negative 5 squared plus 4 times 5 plus 4 all over 5 minus 4. So when I plug it in on my calculator, I'm changing all these 4.5s to 5s. So I'll just delete the 4 point. Notice the wonderful use of parentheses around the numerator and denominator there. And I end up getting -1. Don't care what the number is, it's negative. What kind of answers are we looking for on this problem? Greater than or equal to 0, which are the positive answers. And the positive answers are here, between -infinity to 2 minus 2 squared root of 2, and then in here, between 4 and 2 plus 2 squared root of 2. So the answer, written out in square root format, interval notation, is -infinity to 2 minus 2 square root of 2, bracket, because you want to include that point, union 4 to 2 plus 2 square roots of 2, and because we want to include that 2 square roots of 2, bracket. There's my answer. Does that make sense? Did I lose you guys anyway? This is the hardest one of all because the quadratic didn't factor. Just they threw that one at you just to keep you guys honest. If it doesn't factor, quadratic formula. But let's do these other two problems. Let's do this one. This is going to be a little nicer. Number 4. Question. Yes, ma'am.
So like normally x squared plus 4x plus 4 would factor. So if the reason it didn't because of the negative.
Yes. That negative out front. So if it was a positive, that would have, but it wasn't. It was negative. So that makes it negative x squared plus 4x plus 4 doesn't factor. And like you say, when you did the quadratic formula, you got weird numbers like 2 plus or minus 2 square root of 2. Okay? So let's take a look at the next one, and I'll use a nice clean sheet of paper for that one. So here we go. Number 4 here. Just because I ran out of room, because that one with the quadratic took a little more room. X minus 3 divided by x squared minus 2x plus 1 is strictly greater than 0. All right. Well, step 1, set it to 0. But what's nice about this problem? It's already set to 0, so I don't have to worry about common denominators on this thing. Don't worry, we got one more to do. You'll enjoy that one. But this one, no, we don't have to worry about that. We already got it set to 0. So this is my function. F of x is x minus 3 over x squared minus 2x plus 1, and we're setting it greater than 0. The first thing I want are my zeros. How do I find zeros when I have a rational function? We're going to set the numerator equal to 0. What's my numerator in this problem? X minus 3. Set it equal to 0 and solve. X equals 3. Question. Do you want your zeros in this solution set? No. Why? Because inequality does not have equal to on it. So this would be an open circle. What are the vertical asymptotes, the points that don't exist on this thing? You set the denominator equal to 0. My denominator is x squared minus 2x plus 1. Set it equal to 0. This quadratic does factor. How does it factor? X, what times what is 1? That adds up to be 2. 1 and 1, and the signs have to be minus, minus. Set each factor, it's the same thing, equal to 0, and you get one answer, x equals 1. Do you, the vertical asymptotes, do you ever want vertical asymptotes in your answer? No. No, denominators can never be equal to 0, so that's an open circle. So now, I got my equation. I'm going to draw my number line for it, and I'm going to put my two numbers on there. It's 1 and 3. 1 and 3, but they both get open circles. Vertical asymptote always gets open circle because there's no equal to on the inequality. Your 0 gets also an open circle. Now let's do our test values. Pick a number between negative infinity to 1. Use your brain. Good choice. 0. So f of 0 would be 0 minus 3 over 0 squared minus 2 times 0 plus 1. That equals negative 3 divided by 1, which is negative 3. Don't care what the number is, but the sign is negative. Pick a number between 1 and 3. Now I choose 2. F of 2. This will be 2 minus 3 divided by 2 squared minus 2 times 2 plus 1. 2 minus 3, negative 1. 2 squared is 4. 2 times 2 is 4. 4 minus 4 is 0, plus 1 is 1. What is negative 1 divided by 1? Negative 1. What's my sign? Negative. It didn't change signs is my point to this exercise. Pick a number bigger than 3. 4. This will be 4 minus 3 divided by 4 squared minus 2 times 4 plus 1. 4 minus 3 is 1. 4 squared is 16. 2 times 4 is 8. 16 minus 8 plus 1. 16 minus 8 is 8 plus 1 is 9. I get 1/9, but don't care what the number is. It's a positive number. Does that make sense? What kind of answers do I want here? Greater than 0, so we want the positive answers. Positive answers are here. So what is my answer to this particular problem in interval notation? Parentheses, because you can't include it, 3 to infinity. And there's my solution. Does that make sense? Did I lose you guys anywhere? Well, let's do one more hard one. And that one is this one here, number 5. And if you notice, this problem was supposed to be onto the other page because we've got a nice blank page on this thing. So I'm just going to transfer it over. This will be 5 divided by x plus 3 is greater than or equal to 3 over x. Now this one will be the hardest of the problems here. Why will this one be the hardest of the problems? Because I've got to set it to 0 and then I really got to go for a common denominator besides 1 and something else. So first thing I got to do is set it to 0. I'm going to subtract 3 over x from both sides. This is going to be 5 over x plus 3 minus 3 over x would be greater than or equal to 0. But I've got to create a fraction, okay? A rational function fraction. So what I'm going to do here is get a common denominator. What's my common denominator between x plus 3 and x? My common denominator, if there's nothing in common, just slap them together. X times x plus 3. What did you do to x plus 3 to get an x times x plus 3? You multiplied by x. But whatever I do to the bottom, hit the autofocus here so you guys can see this. Whatever I do to the bottom, I've got to do to the top. Whatever I do to the denominator, I got to do to the numerator. So I'll put an x down here, I got to put an x up here. That makes a 5x. Don't cancel. It's kind of the whole point is to get this common denominator. It's a minus there. What did I do? What did I multiply by x by to get x times x plus 3? I'll multiply by x plus 3. So what I do to the bottom, I do to the top. So this becomes 3 times x plus 3. Still greater than or equal to 0. But now you've got a common denominator. You write it over one big common denominator, x times x plus 3, and you put all your action in the numerator. 5x minus 3 times x plus 3 is greater than or equal to 0. Let's clean this up. This negative 3 is going to distribute. So this is 5x minus 3x minus 9. Negative 3 times a positive 9. 3 is a negative 9 over x times x plus 3. Greater than or equal to 0. And now clean it up. What's 5x minus 3x? 2x minus 9 over x times x plus 3 is greater than or equal to 0. This is my function. Now, we got to find the zeros. How do I find the zeros? When I finally get it down to a fractional form, you set the numerator equal to 0. So you take your 2x minus 9, set it equal to 0, and solve for x. Add 9 to both sides. I get 2x equals 9. Divide by 2 on both sides. X equals 9 halves. Question. Do you want your zeros to be in the solutions of this problem? Yes or no? Yes. Why? Because the problem is equal to 0. That equal to means we want him. Now we got to find the vertical asymptote. So I'm going to set the denominator equal to 0. What's my denominator? X times x plus 3. I left it in factored form. So I set each factor. X is a factor, equal to 0, and x plus 3 equals 0, which means x equals negative 3. So 0 and negative 3 are my vertical asymptotes, and they're always open circles. You can never include those guys. So now I'm going to draw my number line. Now I'll put these numbers in order. Negative 3 is the smallest because it's negative. Then there's 0, and all these are open circle here because they're the vertical asymptotes. And then there's 9 halves, which is 4.5. But that's a 0 because the equal to, we want him to be equal to 0. So that's a filled in dot there. Again, my function for my number line is 2x minus 9 over x times x plus 3. So let's pick some test values and check it out. Pick a number less than negative 3. So f of negative 4 would be 2 times negative 4 minus 9 over negative 4 times negative 4 plus 3. 2 times negative 4 is negative 8. Minus 9 is negative 17. Negative 4 times plus 3 is negative 1. Negative 1 times a negative 4 is a positive 4. So I get negative 17 over 4. I don't care what the number is. What's the sign of it? Negative. So everything in here is negative. Now, pick a number between negative 3 and 0. I choose negative 1. This will be 2 times negative 1 minus 9 over negative 1 times negative 1 plus 3. 2 times negative 1 is negative 2. Minus 9 is negative 11. Negative 1 plus 3 is 2. And 2 times negative 1 is negative 2. Negative 11 divided by negative 2 is a positive 11 halves. Who cares what the number is? The sign of it is positive. Now pick a number between 0 and 9 halves. 9 halves is 4.5. I pick positive 1. This will be 2 times 1 minus 9 over 1 times 1 plus 3. 2 times 1 is 2 minus 9 is negative 7. Over 1 plus 3 is 4 times 1 is still 4. It's negative 7/4, but it's still negative, and that's all I care about the sign. And then I got to pick one more. Pick a number bigger than 9 halves, 4.5. Choose 5. F of 5 would be 2 times 5 minus 9 over 5 times 5 plus 3. 2 times 5 is 10, minus 9 is 1. 5 plus 3 is 8, and 8 times 5 is 40. I get 1 over 40. Don't care what the number is. What's the sign of it? Positive. What kind of answers are we looking for in this problem? Greater than or equal to 0, so we want the positive ones. Shade in the positive answers. And let's write the answer in interval notation. And here's the problem with this type of stuff that frustrates students. This is math. They should get the answer in 10 seconds or less. No, you're in college. Those days are long since gone. This is going to take some time. Do the steps, watch the methodically go through the steps, watch the careless errors, you'll get it. What's my answer here? Parentheses, -320, parentheses, because you can't include these guys, because they're the verbal asymptote, the denominator equals 0. But then there's a union bracket, because we want to include the 9/2, 0.2, where we're stopping at? Infinity. Infinities always have open parentheses. And there's my solution. Does that make sense? Questions? Well, moving on. Chapter 7.1. Seven point one is about exponential functions and their graphs. Okay? So, an exponential function is a function of the form of f of x equals some base a has to be greater than 0, has to be a positive base, raised to the x. You will notice that the variable is in the exponent. This is why it's called an exponential function. Okay? Examples of exponential functions, or exponential equations for that matter, is equations that have the variable in the exponent. So for example, find x for each one of these guys. 4 is equal to the x, 27 equals 3 to the x, and 2 equals 4 to the x. Let's solve for x here. Well, what does x have to be equal to? In other words, what do I need to raise 2 to get 4? What do I, 2, because 2 squared is 4. What do I need to raise 3 to in order to get 27? 3 raised to the what is 27? 3 raised to the third power, x equals 3. 3 cubed is 27. But, look at this one. X is equal to 2 is equal to 4 raised to the x. What does x have to be, in other words, to take a 4 and break it down to a 2? Very good. The fact is the square root of 4 is equal to 2, right? But we don't do square roots when we're talking about exponents. A square root is a fractional exponent. And what fraction is it? To the 1/2 power. So 4 to the 1/2 power equals 2. So the exponent had to be 1/2. So don't forget your radicals being fractional exponents. But another way we can look at these exponential equations is this. If you can somehow manipulate the equation and write the equation with the same base, if the bases are equal to, so I've got b raised to the m is equal to b raised to the n. If the bases are equal to each other, the exponents have to be equal to each other. So can we manipulate these guys and solve for x? Well, this one isn't too bad. I got 3 raised to the 2x equals 3 raised to the x minus 5. The bases are already equal to each other. So if you're solving for where the bases are equal to each other, what can you tell me about the exponents? That got to be equal. So in other words, that implies that the 2x exponent has to be equal to the x minus 5 exponent. Solve for x. I would subtract x from both sides. 2x minus x is 1x equals, that cancels, -5. My solution is x equals -5. However, look at number 2. They're trying to mess with you. I've got 8 raised to the x is equal to 2 raised to the x plus 4. Solve for x. Problem is, they're not the same base. These are exponential functions, which means you got to know your property of exponents. What are my property of exponents? Let's come over here and let's remind ourselves of properties of exponents. A to the m multiplied by a to the n. When the bases are alike and you're multiplying, what do I get to do with the exponents? Add them. A to the m plus n. When you are dividing, a to the m divided by a to the n, like bases, what do I get to do with the exponent? Subtract a to the m minus n. When I have a raised to a power m, and then we raise the whole thing to the n, a power raised to another power, what do we get to do with the powers? Multiply. A a to the m times n. So, we gotta write these guys in the same base. I've got 8 raised to the x equals 2 raised to the x plus 4. They're not the same base, but I can rewrite 8. What's 8 also known as? 2 cubed. Break it down. 8 is 2 times 2 times 2. 2 cubed. So I can rewrite this, replace the 8 with 2 cubed raised to the x equals 2 raised to the x plus 4. But now we've got to use our property of exponents. I have a power, 2 cubed, raised to another power, raised to the x. A power to a power, what do I get to do with the powers? Multiply. This gives me 2 raised to the 3x is equal to 2 raised to the x plus 4. Once you can write it with the bases equal to each other, what does that imply? Exponents are equal to each other. 3x is equal to x plus 4. Solve for x. I would subtract x from both sides. That cancels. 3x minus x is 2x equals 4. And then I divide by 2. And that gives me x is equal to 2. My solution. But they're going to try to mess with you with fractions. So let's take a look at these next two. I've got 2/3 raised to the x is equal to 9/4. Okay? 2/3 raised to the x equals 9/4. But you can break down 9/4. Other property of exponents that we've been talking about is this. A to the n divided by b to the n is the same thing as a divided by b to the n. And a times b to the m is equal to a to the m times b to the m. You can distribute powers, oops, I wrote it off the screen there. You can distribute powers through strict multiplication division. So, 2/3 to the x equals 9/4. What exactly is 9/4? Break down 9/4. 2/3 to the x is equal to, well, let's see here. 9. What exactly is 9? 3 squared. Over what exactly is 4? 2 squared. Does that make sense? So in other words, I've got this again. 2/3 raised to the x is equal to, so they have the same power. I can, in strict multiplication division, I can factor the power out. Raised to the 3/2 squared. But they're not the same base. Well, how can I change that? They're almost the same base. There's a problem. They're flipped, right? So, what can I do to this guy inside to flip him? What flips a fraction? Negative exponents. Remember, a raised to the negative n is 1 over a to the n. Again, you'll notice what I'm doing here is playing all my property of exponents. A raised to the negative 1 is 1 over a. It flips the fraction. So I can rewrite this guy as 2/3 to the x is equal to 2/3 to the negative 1 to the x. Because I just want to show you, what is 2/3 to the negative 1 also known as? What's anything to the negative 1 power? It's 1 over 2/3. But what's 1 over 2/3? When you divide by a fraction, what do? Flip and multiply. Multiply by reciprocal. That's 3/2. So 2/3 to the negative 1 is equal to 3/2. Now I have it as the same fraction, but a power to a power I got to multiply. So this gives me 2/3 to the x is equal to 2/3. Negative 1 to the x would be negative x. Also negative, that's a 2 there, sorry about that. To the negative 2. Negative 1 times 2 is negative 2. And once the exponents, the bases are equal to each other, what does that imply? Once I write the bases equal to each other, exponents have to be equal to each other. X has got to be negative 2. There's my solution. And of course, you can go back and double check this stuff on your old calculator. What is 2/3 raised to the negative 2 power? The answer was negative 2. What do I get? 2.25, which when you convert it to a fraction is 9/4. And it checks. Now let's take a look at this guy here. See if I can squeeze him in here. All right. I've got, this is a great problem to study. Watch what I do. Take good notes. I've got 1/5 raised to the x minus 4 equals 625 raised to the 1/2. Clearly, they don't have the same base. But what number can I raise it to get 625? What number can I raise and get 1/5? You've got to think about fractions. Fractions are negative exponents. So, things we know. 1/5 is the same thing as 5 to the negative 1 power. Does that make sense? Because negative exponents puts them on the bottom. Something else you should know. 625 is 25 times 25. But 25 is 5 squared. 5 squared times 5 squared is 5 to the 4th power. So things we know based upon numbers and playing with them, 625 is 5 to the 4th, and 1/5 is 5 to the negative 1 power. So I can substitute this in. This is 5 to the negative 1 power raised to the x minus 4. That's going to be equal to 5 to the 4th power raised to the 1/2. I'm trying to squeeze it in there. So let me rewrite it down here. 5 to the negative 1 to the x minus 4 is equal to 5 to the 4th, 625, to the 1/2 power. But what do we get to do when we have a power raised to another power? What was my properties? And they're right over here, right to the side here. Power to a power, right? No, they're actually up here. Power to a power, what do we get to do? Multiply. So this will be 5 raised to the negative 1 times x minus 4 is equal to 5 raised to the 4 times 1/2. Almost there, squeezing it in. If the bases are equal to each other, the exponents are equal to each other. Negative 1 times x minus 4 has got to be equal to 4 times 1/2. Distributing here, this is negative x plus 4 is equal to, what's half of 4? 2. Subtract 2 from both sides. I should subtract 4 from both sides. That gives me negative 2. So it cancels here. I get negative x is equal to a negative 2. Divide by negative 1. And I get my answer, and I'll squeeze in here. X is equal to 2. X equals 2. And then I can go back and double check it by doing this. Parentheses. 1/5 raised to the, I got x equals x equals 2. Let's see here, 2 minus 4. Typing it in, I get that. And if I take 625 and raise it to the 1/2 power, I get 25. So you notice when I plugged in x equals 2, it works for both of them. Does that make sense? But remember this trick in terms of writing your bases as the same, then the exponents have to be equal to each other. Now, graphing this guy. Exponential functions, okay? When you look at it, now this is for a base A, which has got to be greater than 1. That's very important. Your base is bigger than 1. This is what the exponential function looks like. The domain is all real numbers, negative infinity to infinity. But when you graph an exponential function, it horizontals out on the left and blows up on the right. This is the shape of an exponential function. Lots of things in the world pattern themselves after exponential functions. Okay? Population growth, money growth, let's see here, radioactive material can grow or decay according to the same type of exponential graph and stuff. So this is what the graph looks like when you have a base that is bigger than 1, raised to the x. It looks like this. Now, what we want to do is we want to graph this guy here. But we want to use the techniques of shifting, stretching, and reflecting to do this. So on this particular problem here, on this particular problem, I want to start with the basic graph. My basic graph is this: y equals 2 raised to the x. I want you guys to know what that graph looks like. It patterns itself after this one, but I want to plot some points. So I'm going to graph this guy by plotting some points. And since the domain is all real numbers, you should always plot a couple of negatives, 0, and a couple of positives. So I'm going to plot -2, -1, 0, 1, and 2. Now let's see what you guys can do with this. The function is 2 raised to the x. So here's 1, here's 2, here's 3, here's -1, here's -2, here's -3, here's 1, 2, 3, 4, -1, -2, -3. All right, so let's plot this thing. -2. What is 2 raised to the -2 power? Negative exponents. How do you clean up a negative exponent? It goes on the bottom. So this is 1 over 2 squared. What's 2 squared? 4. So it's 1/4. So when x is -2, you get 1/4. It's the point -2, 1/4. Plug in -1. This will be 2 raised to the -1 power, but a negative exponent goes on the bottom. That's 1 over 2 to the first, and 2 to the first is a half. So at -1, you get a half. 0. What's anything raised to the 0 power? What's 2 raised to the 0 power? 1. So I get the point 0, 1. So you know this is growing. Plug in 2. I'm plugging 1. That'll be 2 to the first, which is 2. 1, you get 2. Plug in 2. The function is 2 to the x. 2 squared is 4. 2, you get 4. And you connect the dots. Horizontal's out on one end and blows up on the other. This is your basic graph of y equals 2 to the x, which follows the classic pattern of this guy up here. But let's see what you guys remember about techniques of shifting, stretching, and reflecting. I've got y equals 2 to the x. We want to graph y equals 2 to the -x. We're replacing x with -x. By plugging a negative inside the parentheses, it has an effect. What effect does it have? Outstanding. It reflects over the y-axis. By replacing the x with a -x, reflects over the y-axis, not the x-axis. Negative outside flips it upside down. Negative inside where the x is at reflects it over the y-axis. So what is this graph going to look like? Well, it'll be, these points will flip over here. It goes through this point. So instead of 1, 2, it'll be -1, 2, -2, 4, 1, a half, 2, a quarter, and you get this graph. But the point I'm trying to make is, basically I took this graph and reflected it across the y-axis. That's what a negative inside your x does for you. Negative outside flips it upside down. Negative where the x is at reflects it across the y-axis. Now what about this guy? We got our basic graph up here. My basic graph is y equals 2 to the x. What do I have to do to get my function f of x is equal to 2 raised to the x minus 1 minus 2? I see two things going on here. The first thing is this. Inside the parentheses. Inside the parentheses, it's x minus 1. That is called a horizontal shift. What is your horizontal shift? Which way is it going to go? Which one? Right one. Very good. Minus 1, remember, inside the parentheses had the opposite effect. This is going to go right 1 unit. And then what about your vertical shift? What is that minus 2 going to do for you? Down 2. So we're going to take this graph up here. We're going to shift him right 1 unit and then down 2. Focus on the point 0, 1. Here it is. I got to go right 1 unit and then down 2. 1, 2. It becomes here. This point is horizontaling out. When you go right 1, it's still horizontaling out, but then it's got to go down 2. So down 2 would be right here. So you got a vertical asymptote that's going down this way. And this point, at the point 1, 2, has to go right 1 and then down 2. So it goes through this point here. And there's my graph that has been shifted right 1, down 2. Does that make sense? Questions? Play around with these guys, because what's coming next is word problems. Section 7.2, applications of this exponential function. So let's just get started on this. There's a very important number that we talked about before, which is E, which is 2.71828. Now, we're going to be looking at exponential functions that look like this. Y equals E to the X. The nice thing about this guy is the calculus aspect of it. And I'm going to talk about why this thing is so important in our next lecture, but it has a calculus component for the other guys going to be taking calculus. The rate of change of e to the x, or the derivative of e to the x, is e to the x. So you see a lot of mathematical formulas with this e stuff in there. I bet you've seen these kind of functions before. We'll be looking at these guys again. Study hard, and I'll see you guys on Wednesday.